Good morning, good evening to everybody joining our second day of the photovoltaics event. And now I have the pleasure to introduce Armin Wedel. Armin Wedel is the Division Director for Functional Polymers at the Fraunhofer IAP in Potsdam, Germany. And he will tell us a little bit about additional ways of energy harvesting today. And with that, Armin, over to you.
Yeah, thank you, Christoph, at first for the introduction and also for the opportunity to present a summary of our work in photovoltaics in the different ways. And I think I can give you some hints about the developments which we had in the past and which we are looking in the future. And this is a summary of our photovoltaics activities. I think we can divide it as in 4 parts. The first one is embedding the normal silicon solar cells in polymer matrices, because we are a Fraunhofer Institute of Applied Polymer Research. That's why I think it's very important that we are working here with the development of modules for any design or introduction in other application. Then, of course, we have a history in the organic photovoltaics development, especially in the development of new materials and devices. I will show you some of these results. And then we are concentrated also on perovskite solar cells. Here, especially only with the development of printing technologies, especially for the perovskite layer. And last but not least is the use of additional areas for energy generating or harvesting, especially for facades or windows, with the help of fluorescent collectors on dyes and quantum dots. I think the embedding of silicon solar cells, it's a little bit tricky, because to make such modules very transparent without bubbles, and especially in a geometrical design. So here we're using the polymerization technique of MMA through UV polymerization, or we're using a matrix of soluble polymethyl methacrylate, which have very good optical and mechanical properties. So we can also arrange the solar cells between suitable plexiglass plates and or gluing the solar cells with possible encase by EVA foils onto PMA plates, so that we have a great variety for embedding such solar cells for the different application, maybe in the rooftop of cars, for example. We make a project on that one. The next one, I think it's the organic photovoltaic. And here also the speciality of the Fraunhofer IAP is the printing technologies. And of course, it's the development of ink formulations especially for the absorber polymer materials. And of course, we have heard it in the talk before, to use environmentally friendly solvents, chlorine-free solvents, to apply in the inkjet printing process. And of course, as you see from the left to the right-hand side in the picture, that we upscaling that to sizes up to 150 to 150 millimeter in our pilot line. Another topic is, which I cannot go in detail, are the ETO-free devices and customized printed OPV devices, I think, which we develop for the different our customer. We have a long tradition in the development also of materials. I think here is an overview about absorber polymer materials and the variation concerning the absorption maxima and the band gap. So for that one, we developed a broad range of materials in the past. So this is one example, and I can give you this example because we can tune the properties of our polymer materials in a different way. As you can see here, that we have 3 different units. We have the fluorine unit, we have the triphenylamine unit, and we have the diethylene benzol pyridine unit. And with this combination, we can tune our materials and to find out which is the best and which shows the best performance. So for that one is one example of the selected materials, MR2 7. And here you can see we can reach independently from the